Okay, Assalamualaikum warahmatullahi wabarakatuh. So, this is example of solving AC circuit using nodal analysis. Okay, so the question is determine I in the circuit of figure 10.5. So, as you can see here, the circuit is in time domain. So, what we need to do first is to convert this into a phasor domain circuit. So, the phasor domain circuit. So right now, your voltage source is converted to phasor domain. So only the magnitude and the phase angle. The phase angle is 0 right now. Okay. And then we have a capacitor. So we need to convert the capacitor into the reactance. Okay. Negative J XC here, which is negative J 1 over omega C. And in this circuit, the omega is 10, okay, radian per second. So this one is negative J 1 over 10 multiplied with 1 farad. So you will have negative J 1 over 10 is 0.1. So this one is negative J 0.1 ohm, and the resistor is 1 ohm. And the inductor also, you need to convert into its reactance value. Okay, so this one positive J XL, which is positive J omega L. Okay, so 10 multiplied with 1, so this one J 10 ohm. So this is inductor, so positive J 10. And you have another resistor value, which is estimated 1 ohm. Okay. So we ignore first the current here, because right now our concentration is on to get the nodal voltage, okay, using the nodal analysis. Okay, so the first step after you have converted into a phasor domain is to identify the reference node. Okay, the reference node we always here. And we also need, the second step is to identify the non-reference node. Okay, so as you can see, we have this node, V1 and V2 here. Okay, but it is very important, okay, to actually analyze, to actually look at the circuit first. As you can see here, between this V1 and V2, there is no elements, okay, between these two nodes, meaning that there is no voltage drop whatsoever between these nodes, meaning that these two nodes are actually has the same value. So I can actually written this as also our V1. Okay, so this is actually not a super node, okay, because V1 here, if I redraw again here, the circuit should be like this. Okay, the same node. Okay, so meaning that we have only one node inside this circuit. Okay, and then the third step is to identify the current direction. So this is I1, I2, and this is my I3 and my I4. Okay, so next is to analyze the KCL at node V1. Okay, so we have current I1 equal to I2 plus I3 plus I4, where I1 is actually a current that flow from this node, which is 2 volt. You can actually, because we have only, no phase, so we can just write down the magnitude. Okay. So this one will become, I1 will become 2 volt minus V1 over the resistor itself. Okay, over 1, so I can just put like this. Okay, and I2 is V1 minus J 0.1 plus I3 is V1 J 10 and I4 is V1 over 1 ohm. Okay, so we rearrange this equation, so you will have this one is 2 minus 2 V1. So this one will become positive J 10 V1 plus, okay, so this one will become V1 negative J 0.1 plus V1 J 10. Okay, so before we proceed, I would like to recall about the complex numbers. So if you have this one, J1, and then if you convert into a polar, so this one will represent as a magnitude 1 with an angle of 90 degrees. So if you negative J1, meaning that this one is magnitude 1 with an angle of negative 90 degrees. Okay. Okay, and then if I have this one, 1 over 190 degrees. So this one I can actually, because you are putting the angle up, okay, going up, so this one should be negative 90 degrees, or in other words, you can actually write down in the rectangular form as a negative, okay, because you have a negative value here, so negative J1. So meaning that if you have like this, J1 here, if you convert this one, it become negative J1. Okay. So for this case, 2 minus 2 V1. Okay. So this one, because I'm putting the J go up, so this one become positive J 0.1. So 1 over 0.1 is positive 10 V1. Okay, and then this J going up, so this one will become negative J. 1 over 10 is negative 1 V1. Okay, and then rearrange this, we will have this one is equal to 2. This one is the real value, positive 2 plus J. So this one will become 9.9 V1. So finally, your V1 is 2 over 2 plus J, 9.9. Okay, is it correct? 10 minus 0.1. Okay, 9.9. So by using this calculator, make sure that you on the complex mode. Okay, so 2 over, you open the bracket, 2 plus 9.9, I close the bracket, then you have the answer, but usually the voltage should be in polar form, so convert into a polar, so you will be given this value. So 0.198 with an angle of negative 78.5. So this is your V1. So finally, we have obtained the V1 using node analysis. Okay, the next move is to answer this question. So V1 here is 0.198 with an angle negative 78.5. Okay, so you have this node and this node, which is 2, angle 0, and you have this one, node is 1, negative 78.5, and this one is 1 ohm, and the resistor and the current here. So the current, you can just obtain it by using this voltage minus this voltage over 1 ohm. So by using calculator, simply just insert -2 minus 1.198 with an angle of -78.5. So the answer convert into a polar form. So you should have the current is 1.97 with an angle of, so you need to have shift, okay, sorry, shift equal, so 5.65 ampere. So this is in polar form. Okay, so if the voltage right now is given in a time domain, so your final answer should be in also in time domain. So this polar form you can actually convert it or can be written in the time domain by very simple, just write down the I, which is this one. The magnitude is 1.97, and since the voltage source is in the cos term, so just write cos, and then the omega is 10. So just follow 10t, and the phase angle is positive 5.65. So this is your final answer for these questions.